Now we are discussing about motion and their graphs further related to it. Whenever we are considering a body in motion, it kind of factors it has might be distance, speed, velocity, or displacement. Further, what we are going to find the slope of the body when the graph system is included. Whatever the graph system is, we have x-axis and y-axis. X-axis and y-axis. And two factors of the particular speed, displacement, velocity are given, such as for distance time graph, we will be given distance along the y-axis and time along the x-axis. After that, the point of the image or the line of the image represents the motion of a body. Always try to understand that the line or the image that will be drawn on the graph represents the motion of the body. Further, you have the distance time graph. The conditions are such like this: the body is at rest, body is at uniform speed, body is at non-uniform motion. That is the non-uniform speed. Okay. After, when the body will be at rest position, the body will remain at the same distance for a long time. Okay. This long duration represents that time is passing on and the distance remains unchanged. So the body will be at rest. After that, this bisected lines of x and y represent that every point of this body or motion is uniformly increasing, or you can say that the speed will be in uniformity, or the distance is increasing as respect to the time, which will give you a uniform speed of motion. And non-uniform speed will be represented by a curved line, that is the parabola of a curve. That is the non-uniform speed. This is considered to be a distance time graph, where the y-axis is considered to be the distance and x-axis is considered to be the time. These three graphs are most important for the distance time graph for 9. After that, we have displacement time graph. Now, what is the displacement? Displacement is the shortest path covered by an object in a specified direction having a vector quantity. Now, if a body does not cover any distance or displacement and remains along the same point for a long time, it will be a stationary body, but it will have a constant velocity if the time is changing and the body does not displace it. It will be at stand rest. After that, if the body displaces again and again with respect to time uniformly, it will be uniform or constant velocity. Uniform or constant velocity. If the body has a curve at the graph having displacement and time as its factor, so the curve represents the non-uniform velocity. After that, the most contradictory case, that the expected one, which can be asked in the Olympiad or NTSC section starting, the body having perpendicular y-axis at the displacement or distance part. This will be the displacement. This represents that time is passing on and a per second time, that the time will be constant, but the distance increasing again and again for the same time. This is the infinite velocity case. Infinite velocity case, which is contradictory. After that, we are going to learn about the last part, that is the velocity time graph, most important for exam. Now, the slope of the graph, what it gives, let us understand. Slope of distance time graph gives speed. Okay, for example, tan theta will be covered by t2 minus t1 upon t2 minus t1. This will be the slope of the graph, whatever is asking for distance time graph. Now, displacement time graph will give velocity. What will be the velocities? It will be calculated by the slope of displacement time graph. After that, for the particular instance, tan theta will be the remain same for p by h. That will be equal to d2 minus t1 upon d2 minus t1. After that, when it comes to the velocity part, what is velocity? P is equals to u plus a2. Now, this equation can be considered in the velocity time graph after the consideration of the graph, that the graph having y-axis and x-axis having the time period as t and velocity v. Since the velocity is increasing and the time has changed to the past more and more, the velocity does not increase. That means the body will remain at constant velocity, or the body will not change its velocity until the time changes. Means that the body does not accelerate. It has velocity, changing tack but does not accelerate. We all have seen accelerators on bike. If it will have a constant acceleration or constant velocity, it doesn't accelerate anymore, so the graph will be straight parallel to the time. This is the velocity time graph. After that, the second one most thing, the most asked question, if this particular case will have the bisector line for velocity and time, this will be a constant acceleration or increasing velocity. Velocity is uniformly increasing, that means acceleration will be constant. Acceleration will be constant just because the slope will remain same ratio. For example, v2 minus v1 divided by v2 minus v1 will be acceleration. Okay. After that, if the body have increasing acceleration, then it will have a deceleration, that is called retardation, which means a certain decrease in the velocity. And this velocity decrease will be noted as v1 minus v2 upon v2 minus v1. This is the retardation point when the velocity with its motion will remain what? 0. Understood? Now the decreasing velocity will remain. This is the most asked question for 9. This one is also the most asked question for 9. Uniform acceleration. Non-uniform acceleration, or you can say about retardation. It is considered to be negative. And the one most important question to be asked, that we have displacement, velocity and acceleration calculated to be negative, positive or zero. Because they both have their negative, positive and zero respectively. So we go.
इसको हम डालेंगे YouTube में.